Shiva sir, we can start sir. He will join within 2 minutes. Some technical glitch, he will be joined within 5 minutes. We can proceed sir.
Okay. Okay. I'm sharing my screen. Is it visible?
Yes sir, it is visible.
Okay, I'm doing for one project. Actually, this is a board for thermal simulation. First, after opening the board, we need to import the stack up. Okay, once after importing the stack up, we need to assign the EM and EMP formula, EMP MNE files, like your model, assign thermal model.
Sir.
IDF. Yeah. Okay, after importing this EM and EMP file, once we need to save and close the tool. Once after importing EM and EMP, no, the HLT file will be generated. So we need to edit this HLT file in Notepad. In this HLT file, which contains each component, the parameter gap conductivity, junction temperature, and the power dissipation. For example, this parameter gap. This is a standard air parameter gap we are considering. So we need to embed.
Actually, this
Uh,
notepad file is created by ourselves or
no, once you import the EM and EMP, no, after that the tool automatically it will generate in that path.
okay. But how to get to know 3.93 something this values and all? It
Sorry,
is
this is a standard value. The gap conductivity for air is this is a standard value.
okay. This will be vary from based on the different gaps or
No. This is standard for all.
okay. Fine
Whatever
sir.
we are whatever we are embedding in this .hlt editing, no, all are like standard values.
Okay sir. Okay.
Okay, once you give replace all, no, for all components, it will get replaced. Similarly, the gap conductivity, which is 0.16, replace all. Then this is 3.937 into 10 to the power of minus 1, and gap conductivity is 0.16. Then this junction temperature limit is it's 150. Replace all. Then this thermal conductivity of the inner package. So these are the five components we need to
Actually, in this track, I have one doubt. Here it is you are choosing from the track. This one.
no, no, that is no, because once you started editing, no, the options, for example, if you do for one project, no, if
Okay.
you do for some other projects, so it will directly come in track. If
Okay.
you are doing first time means like
We need to give,
if
right?
you edit
We
here,
need to
no,
add.
we need
How
to
to
do.
add it
Yeah,
actually?
yeah, we need to. See here it will come
Okay.
like after. So again, the same thing you need to copy here.
Okay.
For example, replace with here it will come, no, like you do control V.
Okay.
Here initially the value is something different. Here we need to give some 80 or
Okay.
85, no, 85
Okay.
standard. So replace all.
Okay. 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 Okay.
That's it. And power dissipation is like we need to give 0.01. Power dissipation is because here no it contains all active and passive components. For passive components, customer didn't ask any. There is no power dissipation actually, but we are considering 0.001 as power dissipation for all passive components. After this, we need to save and close. Yeah, after editing this HLT file, once we need to yeah here the E which contains the environmental conditions like what is the incoming air temperature or the ambient like which is given by the customer. For example, consider this as 70 and which indicates the board location whether it is in rack or whether it is a single board or it is a left to the rack, right to the rack. Consider the board is in rack and this guard width is we need to embed the stack up thickness in inches. For example, 0.0999 kind. This is stack up thickness in inch and here we need to embed whether it is a board is a open rack or closed means whether it is a hermetically sealed or a open board. And if there are multiple boards means we need to check what is the board spacing from the other board. And here the power dissipation from the other boards. For example, if two boards are there, what is the power dissipation from the other board we need to enter here. Consider like 10 watts power dissipation from the other board. Okay, and is it audible, right?
Yes, sir. Yes, sir. Yes, sir. It is audible.
Okay,
Actually, how to
okay, here
actually
it
how
shows
to
the
fix this
temperature.
one power dissipation value is 10 watts something. It is you are fixing, right? Power
This is the
dissipation.
customer will, for example, if it is a single board,
Okay.
no need to no need to add this. It's
Okay.
actually adjacent board power dissipation.
Okay.
If there
Okay.
are multiple boards, no, in rack, so
Okay.
we need to take the power dissipation from the adjacent board. This one customer will only give.
Okay. Okay. Okay, sir. Okay, sir.
Okay, just I'm taking open board, and here we need to click on the component. For example, say S1 component. If you edit this part, it will ask like this. First one is class. I mean, which one it is, whether it's a DIP component or BGA component or SMD medium needs, which one we need to enter in class. And after that, we need to enter the power dissipation for that one,
Actually,
for
any
that
specific
particular
reason
component.
to select OTS particular part?
Sorry.
You have chosen one part, right? Name of the part is 0TS hyphen 24 something is there, right?
Yeah,
Part
this
name.
it's a part number. Yeah,
Some device, right?
reference is
Part
going
is
to the
some component, right? Actually,
yeah, it's a
any
some
particular
component.
reason for to select that particular component, or we can select
No, no, no.
randomly or based on power consumption?
We need to do for active components.
Okay, okay, sir. Okay,
So here there might be some VRM, buck converter, boost converter, or sometimes they will do some for MOSFET, but it should be an active component.
okay, sir. Okay, okay. Passive we are not going to
But
consider that one.
no, passive is which is not having too much power dissipations. No,
Okay, okay.
passive anyhow. While doing that HLT file, no, we are
Mm-hmm.
giving 0.001, right?
Okay, okay, okay. Right.
There only we are giving power dissipation for passive, so we no need to enter here.
Okay, sir. Okay.
And consider this is some like kind of regulator.
Okay, sir.
For this one, first we need to enter the package, whether it is a BGIC or it is a SMT medium needs, which one we need to select here. And power dissipation, we need to remember what is the power dissipation of that IC.
Okay.
And here already see we have edited no that air gap. Here all it will be coming here. This
Okay.
air gap and causing temperature and junction limit temperature. And this power dissipation, for example, for this particular IC, it is a 4 watt means we need to enter 4 watt here. And junction theta JC value, junction to casing value. Consider it might be around 0.3 or 0.4 like that. And here left right means we need to take the size of that particular IC. For example, yeah, consider this is on reference designator. What is the length and what is the width we need to take? Length and width. Then we need to enter here length divide by 2. Here half value, here half value, and width divide by 2. Here half value, here half value we need to enter. Whenever we are taking on IC, no, we need to first enter this one a class, then the size of that one, then power dissipation value, theta JC value, and the temperature.
Sir, actually, why we are divided by two? The value divided by
Because it
two.
is
Yes.
because it is taking a center of component half of like it will take
Okay,
with
okay.
respect to
Origin. It's
center.
kind of origin, right?
Yeah, yeah,
Left
it's a kind of
origin.
origin. Yeah.
Okay, okay. Okay, sir. Okay.
So they are dividing, no? So we need to divide.
Mm-hmm.
Yeah, that's it. We need to give OK. Okay. Similarly, for all components, we need to enter like this. After entering, once you give run, no? Yeah.
So now it
It
is
shows
showing all
the
the active component power dissipation, temperature, all the active,
particularly for one I have entered
only one component.
only
Okay,
for
okay,
only for one because I need to enter for all this. No, it will take time.
okay,
For one,
okay.
I'm showing.
Okay, at a time we
See, I
can
have
able to
entered there.
see only one, right? May correct?
No, no. For thermal, we need to enter all at a time.
Okay, 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 okay.
For example, after this, you need to enter for this.
Hmm.
After this, you need to enter for this. So like this, for all you need to enter.
Okay, sir. Okay, 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 okay,
After entering, it will show the results will be coming like this.
okay,
And 94 is the bore temperature we are getting, and the red area here it is indicating that hotspot area. Like this, we are checking. Yeah, and here we can see, uh, for example, embedded for this one. No? Yeah, here we can see for S1, the a component temperature we are getting is 90.3, junction temperature is 91.7 we are getting, and power dissipation what we have added is it's 3.65. For example, this X1 component here the junction temperature is 150. We are getting junction temperature is 91.5. Then it is pass. If the junction temperature is 150, here we are getting more than 150, like 160, 170, no, then the component is fail. Like this it is.
uh,
Yeah,
here where it is mentioned maximum power dissipation or temperature, junction temperature value, it is there,
here,
maximum
junction
junction
temperature.
temperature. Okay, so if it is in less than 150 it is getting passed, right?
Yeah, for every component there is some junction temperature.
Okay,
For
okay,
one
sir.
IC it is maybe 150. For one IC it may be some 90 only. So
So
we need to check.
this data we are
Af
get it from data sheet, junction
Data
temperature.
sheets. Yeah, data
Okay,
sheets.
okay.
Yeah, data sheets. So. we are get here for example, this IC contains only 85 junction temperature,
Mm-hmm.
but here for that one we are getting 91.7. So we are failing by 10 degree. This
Okay.
component is failing by 10 degrees Celsius.
Okay, sir. Okay.
Yeah, this is the results. And once I'll share you the report formatting also, how we are giving the report and all.
Okay, sir. Okay.
Then further any doubts?
Suppose if it is getting failed now, what we are going to do for make it as pass? Generally, for leakage and all, introducing some decoupling or resistor pull down, pull up. Here, in this case, what
No,
we are
no.
going to do?
In this case, we will confirm that we will inform the customer to reduce the power dissipation value,
Okay, okay,
because
okay,
power
got it.
dissipation only once you reduce power dissipation, no? So the junction temperature will also reduce.
Okay, okay.
Yeah.
Otherwise, we need to change the component, right? No other way if it is.
No, no, component usually the hardware designers and all, they are here we are not changing any components and all.
Mm-hmm.
But most of the cases, no, it will pass either they should reduce the theta JC value,
Mm-hmm.
this theta JC value, or the most of the cases the power dissipation value.
Okay.
And in some cases the bias may needed on pads.
Okay,
In
okay.
rare cases. Yeah. Then and also one more thing, how we are doing for active components, no?
Okay.
Similarly for mounting holes will be there, no?
Okay, okay.
For mounting holes also we need to embed. Here for class is like a screw.
Okay.
For mounting holes power dissipation is zero only. Power dissipation and thermal it's zero.
Okay.
And this is a round component. Then we need to enter the pad size. Sorry, drill size here, pad size here.
Okay. Okay.
That's it. Then
Actually, after screwing, inserting the screw also, it doesn't change anything, right? So it is green
no, no,
color.
I have not
Okay.
changed it. No, 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 I have not. See here, it's a screw.
Okay.
It's a round component.
Okay.
Consider the diameter is 188 like that.
Diameter 188 inch.
No, no, no. I'm just
Okay.
I don't know. Actually, that took small maybe.
Okay. Okay.
Yeah, here.
Okay. So there is no
Um,
power dissipation here.
no, no. For mounting holes, there is no power dissipation.
Okay.
And like this, we need to do.
Okay, sir. For
Then
making report, sir. For making report.
report rate. Report also. Somebody wants to join. Yeah. A report and yeah, this is a report format actually.
Okay. Okay.
Like this is a reference to designator like active components U1, U2. It is like that. And the part number of that. And this is a power dissipation of that. And theta JC value what we are embedding, no? This
Okay.
one.
Okay. Okay.
And
What
this is a theta J maximum.
once prepare this Excel,
Maximum.
then only we can go with software, right? We need to give these inputs to into the software, right?
Yeah, yeah, yeah. We need to give these inputs to the software actually.
Okay. Okay.
I have shared you the input form, no?
Yes, yes, yes. Received. Yeah, that
Yeah,
was
yeah,
also explained.
yeah. That input only we are embedding. After that, we are giving as a report in the report format.
Okay, sir.
And this is side means at what side, whether the component is placed in top or if it is in bottom, like this. Here all are placed in top only.
Hmm.
It's a kind of like that. Here the component temperature, tension temperature, and the temperature difference. How much
Okay.
we are getting. For
Okay.
example, 200 minus 140, like this.
Hmm.
Pass fail.
Actually, what kind of input is given to the customer after failing the component?
Sorry, after failing component, what we are
Going to
suggesting.
suggest to customer or designer.
Um, Most of the times, no. For example, this particular carrying, the power dissipation, it will take only like 4 watt or 5 watt, but most of the cases they will give some high power dissipation. So once we need to verify with the data sheet also.
Okay.
If it is not possible, then we need to reduce the power dissipation, or if it is failing near pads, no, then we have to inform add some wires near to the pad, like that. But here power dissipation matters a lot in this thermal simulation.
Okay, sir. Okay, okay, okay.
Yeah. Then anything.
Actually, how to add multiple active components in that window? Actually, you shown I think one component and how to.
Yeah, yeah. For example, if you here this after running this bar will come now.
Okay, okay,
You just double click on this. See here it will highlight. You
okay,
take this one, embed all the things.
okay,
Okay, okay. Then take this, double click on the second component,
okay,
edit part, embed all. Okay.
okay.
Similarly, for example, this one, double
Mm-hmm.
click on this, embed all. Okay,
Okay.
like this.
Like this, we have to select whatever the active component we have to select like this.
Yeah,
Okay.
yeah,
Once
yeah. We
select the
need
all
to do for
components,
all active
yeah.
at
Then
a time.
how to simulate? Once select the component and give the input.
You just need to click on this run button.
Okay, sir. Okay.
So it will run.
Okay, sir. Okay.
Yeah.
This pattern little bit different than that actually.
Sorry. I tell me.
Okay. Okay, the mounting hole plays a little bit, right? Some changes
Yeah,
might
yeah.
be there.
This now.
Okay.
Yeah, yeah.
Yes, yes.
Actually, here I should check the round component, but still it is in progress. So
Okay,
still I
sir.
need to import the data. Yeah.
Okay.
Okay then.
Okay,
Thank
sir.
you.
Okay, thank you, sir. Thank you so much.
Yeah. Thank you.
Thank you, Suresh, sir.
Yeah. Okay, sir. Thank you.
Thank you, sir.
Bye.
Thank you, sir. Thank you, sir.